Hi guys, welcome again to Simplified RSA. The guys who makes it looks easy. And our question today is gonna be this question here. We'll be doing question 4. So without wasting time, the question reads, below are the graphs of f of x and g of x. So f of x is equals to x squared plus bx minus 3, and g of x is equals to a over x plus p as given. Now, the most important thing when you have a question like this is to look at the diagram given, like the image, your graphs. Look at the graphs and analyze the information that is given. So we have two graphs in one Cartesian plane. It's a parabola graph and a hyperbola graph. Now, they are saying f, meaning f of x, f has a turning point at c and passes through the x-axis at a point 1 and 0. So we can see the way it's going like that. C is the turning point, and it passes the x-axis on at that point where x is equals to 1, as shown on the diagram. D is the y-axis of both f and g. So both f of x and g of x, the point D represent the y-axis for both the graphs. The graph of f and g also intersect each other at E and J. So the graph of f and g have three intersections so far. It's J, D, and E as given like that. The vertical asymptote of G passes through the x-axis of f. As we can see there, the vertical asymptote, it's passing through the point where x is equals to 1, as shown on the diagram. So this is the given information. Now, the questions that we are faced with, question 1, they want us to write down the value of P. Now, we just have to write down the value of P, right? But then which value of P are they talking about? Let's do the thing. So this is how we can imagine our graph colorfully, or the image that is given, right? G of x is given as a over x plus p. And we know that g of x represent the hyperbola graph. Originally, we know that a hyperbola graph is something of this form, whereby here it would be 0. And the standard form would be probably f of x is equals to a over x. This is the standard form of a hyperbola graph, given that this is the y-axis, this is the x-axis. Somehow on this one, we can see that originally it means here it was supposed to be somewhere there, if it was originally from 0, right? But however, now it looks like the hyperbola has moved from 0 to 1, having 1 being the asymptote, and then it goes like that, the curves goes like that. So it shifted 1 unit to the right. So that is represented by P. So to shift 1 unit to the right, it means that this graph should have been a over x minus 1 unit. The reason why it goes as a negative is because if we were to solve this, if x was 0, that's when x will be equals to a positive 1. Hence is a movement to the right by 1 unit. So x is equals to minus 1, meaning P is minus 1, because it's a right movement to the right like that. It's a movement from 0 to 1 on the graph of the hyperbola from the standard form. So P is equals to 1. 4.1 P is equals to minus 1. I mean, not just 1. So now 4.2, they want us to show that A is equals to 3 and B is equals to 2. The question is which A and which B again. So now we know that P is minus 1, right? So if I write G of x now, it would be something of this nature. So now that I know that the value for P is minus 1, then I can write G of x as a over x minus 1. But then now, what would be the value for A? We have to prove that A is equals to 3, according to 4.2. Somehow, we can see that The graph passes through the point D, and the point D is our y-axis for both f of x and g of x. F of x is equals to x squared plus bx minus 3 as given. If I let x to be 0 to get the y-intercept, f of 0 is going to be 0 squared plus b0 minus 3. Therefore, this is going to give me minus 3, meaning I can be certainly sure that the point D is 0 and minus 3. That should be the point D. So now, if the point D is 0 and minus 3, if I substitute 0 and minus 3 here, I can get the value for A. Let's do that. Now, this is the same as y is equals to A over x minus 1, because g of x is the same as y, right? So where there's y, I put minus 3 is equals to A over, where there's x, I put 0 minus 1. Therefore, minus 3 is equals to A over minus 1. Obviously, here we can see that A is indeed positive 3. So A is 3. I can just write it there. A is positive 3 as calculated here. But what about B? What about B? We're talking about this value for B here. The value for B here. So the value for B, the graph of f of x passes the x-axis at the point, this point here is 1 and 0. X is 1, y is 0 here. So if I use this point to get the value of B here, I will have 0 is equals to 1 squared plus B1 minus 3, right? Therefore, this is going to be 0, 1 plus B minus 3. 1 minus 3 is going to be 0 is equals to B minus 2. Now, if I take the 2 to the other side, then B is equals to 2. Therefore, B is indeed 2. So according to 4.1, yes, we can agree that A is 3 and B is 2, like that, from the very same diagram that is given. Now, moving on to the next question. Question 4.3, they want us to find the coordinates of C. And we've been told that C is actually the turning point. So they want us to find the turning point. So now, which turning point? The turning point of the parabola, because that's the turning point of f of x, right? So now we know the value for B. We know B is 2. So if I rewrite that, now that I know that B is 2, f of x is equals to x squared plus 2x minus 3. Because now I know that B is 2 as calculated. I've proved that A is 3, B is 2. So now, to get the turning point, I can either complete a square here. That's the first way. So let me show you the first way by completing a square. If you complete the square here, we'll have x squared, or completing a square, it means I'm going to write this in the vertex form. I'm going to write it in the vertex form. So this is the standard form. The vertex form is, I should write it as f of x is equals to a x minus h squared plus k, something of this form. Therefore, I can show my turning point is h and k, which is the vertex. So to do that from this is just to complete a square from here. So completing a square here, because there's nothing attached to a, I can just go straight and complete the square. So I'll have x squared plus 2x plus half of the square. I add and subtract the square of half of 2. Half of 2 is 1. So it's going to be 1 squared minus 1 squared minus 3. That's completing a square. Therefore, this is going to be f of x is going to be x squared plus 2x plus 1 squared minus 1 minus 3. Therefore, f of x is equals to x squared, or no, I can just factorize from here. So it's going to be x, this x, plus 1 squared minus 4. So this is what we have. Therefore, our turning point or our vertex is going to be, since it's positive 1, it's going to be minus 1 and minus 4. That's the first way of getting this. So meaning the value of the point C is minus 1 and minus 4. So if you don't know how to complete the square, another way to get the turning point is to look at it like this. So as we know that a point is given by x and y, so that would be the representation of point C. Now this is another way to get the turning point. To get the x part of the turning point, we say x is equals to minus b over 2a. Whatever value you get from there, then you go substitute the value from there to get the y value. So x is equals to minus b over 2a. This is going to be equals to b is 2, so it's going to be minus 2 over 2. A is 1. Therefore, this is going to be minus 1. So it means the x part of the turning point is minus 1. What about the y part? To get the y part, we just have to get f of minus 1. So f of minus 1 is going to be minus 1 squared plus 2 minus 1 minus 3. Therefore, this is going to be positive 1, positive 1 minus 2 minus 3. Therefore, this is going to give us minus 4. Therefore, the turning point is minus 4. So it's still giving us minus 1 and minus 4. So this is just the other way to get the turning point. But that just answers our 4.3. So now we are required to write down the range for f of x. So we can see f of x, it goes like that, right? And the vertex is minus 1 and minus 4, meaning the y value here is minus 4, and then the x value is minus 1. That's the turning point. So we can see that f starts from here, and then it goes up to infinity. So we'll say the range of f is y is an element of, it starts from minus 4, and then it goes to infinity. Or you can simply just say y is greater or equals to minus 4, because it starts from here and then it goes up, and we can see it's a minimum. So this is the minimum value, which is minus 4, and then it goes up to infinity like that. So that's the range of f of x. So question 4.5, they want us to determine the equation of the straight line that passes through point C that makes an angle of 45 degrees with the position x-axis. Write down your answer in the form y, But we know the equation of a straight line. We know straight line y is equals to mx plus c. And we know it passes through the point of the, it passes through the point of the turning point. So now we know the turning point already. The problem is to get probably the slope, but let's put it down. So the line passes through point C, but we don't know how. So I'm just gonna imagine something like this. The line passes through C and forms an angle 45 degrees there. So it forms this angle. It passes through C like that, and then it touches C, but then forms the angle like that. Somehow, if this, we know that the equation of a straight line is y is equals to mx plus c, right? Now, to determine the gradient, there's a formula where In this case, we can say M is equals to tan theta. So M is equals to tan theta. Tan theta that is formed by the angle when the line crosses like that. So to get our gradient, it's going to be M is equals to tan of 45 degrees. There's a long story behind proving why I say M is equals to tan theta, but I'll explain. Because the gradient, to calculate the gradient, it's M is equals to change in Y over change in X, right? But somehow, using Pythagoras theorem, I can prove that tan theta is the same as M being change in Y over change in X if we were to construct some Pythagoras going on there, but I'll explain it on another video. For now, just know that M is equals to tan theta is the same or another way of calculating the gradient. So M is going to be tan of 45. Therefore, M is going to be tan of 45 is actually just 1. Tan of 45 degrees is 1. So M is 1. Therefore, Y is equals to X plus C because it's 1M. M is 1 now. Now to get the value of C, since that line passes through, to get the value of, okay, it's a coincidence, we have a C there and we have a C here. So to get the value of this C on a straight line, since that graph passes through the point C, we're just going to substitute what we have. So it's going to be minus 1, minus 4, plus C. Therefore, C is going to be minus 4 plus 1, which is going to be minus 3, which then determines that our equation for the straight line that passes through that point is Y is equals to X minus 3. So that's the equation that this equation here that passes through the point C and forms 45 degrees with the x-axis is Y is equals to X minus 3. That's how we answer 4.5. So 4.6, I just want to know, is the line determined in question 4.5 a tangent of F? Explain your answer. So is this a tangent of F? If we're to have a tangent of F of X, it was supposed to be going like that exactly and have 0 slope. So since here we could determine the slope to be 1, no, this is not a tangent. So the answer for 4.6 is no. So basically, that's how it goes with questions like this. It may look as complicated as it may, but then if one is prepared, there's nothing hard. It's just a matter of just analyzing, reading through the diagram, looking at the question as it is. Otherwise, please feel free to send us an email or WhatsApp text to inquire about our private lessons. Also, please subscribe to our YouTube channel, follow us on Facebook, follow us on X, follow us on TikTok as well as on Instagram. You can also access our learning channel through Spotify by searching for the name Learning Channel, or alternatively just simplified_RSA. I'm Mr. Maimane, this is Simplified RSA, and we are your #1 learning channel.